Hello, welcome to Electronics Education. I'm Vincent Chang. Today we are going to continue our lesson on the AC analysis for semiconductor devices. Alternating current AC analysis and the small signal basics, part 3. Key concept explained. I believe this lecture is one of probably the most important lecture before you dive into the small signal analysis for the transistor amplifier. And I've seen a lot of students and engineers suffer in this area. So my goal for this lecture is make sure you have the right concept. You have the good concept, a good understanding, and lay you a strong foundation in this area before you can conduct the small signal amplifier analysis. Transconductance for the BJT. If we focus on the BJT, then the exponential IV curve can be treated as a straight line under this small signal approximation. VB is much less than thermal voltage. Then you will see a linear relationship between the AC output current and the AC input voltage. So that relationship ratio defined as the slope of this purple triangle, which is defined as the transconductance. All right? Total instantaneous analysis. What is this? Let me ask you this. Let's try to find out the gain, because it's the amplifier, right? Let's try to find out how big is the amplifier gain. Then let's get everyone involved. So everyone means DC, AC, and DC plus AC equals so-called total instantaneous. So let's try to get everyone involved and to find out the AC voltage gain, the amplifier gain. So everyone, including the DC and the AC, the brown, the blue, and the green, then everyone total instantaneous collective voltage equals focus. The VCC deduct the voltage drop across the RC. And because the IC is the total instantaneous current, equals the DC plus the AC. Okay? This is very sensitive when it comes to differentiate the DC, AC, and the total instantaneous. So it's also challenging for you if you are the beginner. So make sure you have a clear writing. All right, so lowercase v, capital V, and subscript also has the differentiation between the lowercase and the capital. Okay, and then the first term is the DC. The second term is the AC. I just try to separate the time independent part and the time dependent part. And now let's focus on the AC output voltage, because our goal is to find out the AC voltage gain, right? So now because under the small signal approximation, so it's linearly proportional to the AC input voltage. See the VBE. And then we can define a quantity called AC voltage gain, which is the AC output voltage divided by the AC input voltage. Again, don't mess up with the three expression, okay? Make sure you have the clear writing if you take note. DC is DC, AC is AC, total instantaneous. So these two, for the AC and the total instantaneous, if we talk about the VC, the same variable, lowercase v, but different subscript. Lowercase subscript is represent AC. The capital subscript represent the total instantaneous. Don't mess up with this variable, okay? Don't confuse between this variable. So now, here's the answer, right? We get the answer. But we get everyone involved. But here's the key. Why you get everyone involved? Because our goal is to find out the AC, right? If your goal is to find out AC, why you get everyone involved? Why you even invite the DC in? You can simply exclude. Not repel, but simply exclude the time-independent component and solely focus on the time-dependent component, which is the AC analysis, right? So this type of analysis or equivalent circuit called AC equivalent circuit. So I'm teaching you right now the concept of the AC equivalent circuit. So at the beginning, in the first place, let's remove all the DC component. So you don't have to get everyone involved. You don't have to get DC involved. The DC not invited. So then the brown one, see, look at the brown one. Brown is the DC, right? Ground. VBEQ equals 0. So the blue signal now is connected to the ground. And then let's also remove the DC collector current, the brown current, the ICQ. So the only now only the AC current, the green current left. This is the second DC. There are third DC, right? Third DC, the one on the top, the VCC, the power supply, the DC supply, also short. Also let the DC voltage equals 0. So your ceiling is also grounded. And then the bottom is also grounded. Okay, now. And then the output on your right, you see the VC, right? So make sure the C is the lowercase. So it represents the AC output voltage. So now, one step. Done. You get it? Only one step. So remember how many steps we did when you get everyone involved. Only one step. You see, VC equals 0 minus IC RC. One step. Done. Bingo! So what have you learned? What have you learned? This is called the AC equivalent circuit. So the one on your right is called the AC equivalent circuit. Then why the students are suffering in this area? Unclear concept leads to confusion. Unclear small signal AC concept leads to a lot of confusion. So to help you clarify, so make sure you don't get confused in the future. When it comes to the AC analysis, small signal analysis, you need a strong foundation at the beginning. You need a strong small signal foundation at the beginning. So let me give you, if you can pass the 3 tests, that means you already have the strong foundation. Test number 1. Puzzle number 1. What is the voltage here? Just tell me. Answer me. What's the voltage at the green point? You see a green point there, right? So now I'm asking you, what's the voltage at the green node? Remember, this kind of question has the problem. The question lies on the problem. You have to ask me back. Teacher, you need to clarify what kind of voltage you are referring to. If it's DC, then 0.7. If you are asking me about AC, let me pause. The green point voltage, if it's DC, is 0.7 volt, right? VBEQ. And then you ask me back, why is grounded? Why is zero now? Why is zero now? This kind of ground is the ground when the DC component is removed, has been removed. This type of ground is called AC ground. It's called AC ground. Same thing with this. The blue node. What's the blue node voltage? You need to ask me back. You have to ask me back. Sir, what kind of voltage you are referring to? I'm referring to DC. Then your answer should be VCC. And why now it's grounded? Why now the ceiling is grounded? Because that kind of ground is when it's the condition when the DC component has been removed. This type of ground is called AC ground. Very important concept when it comes to the small signal analysis. The concept of AC ground, the first test, the first puzzle. The second puzzle, this current is positive or negative. You see a green current, right? Let me ask you, or someone ask you, is this current positive or negative? What is your answer? This trouble a lot of engineers and the students. My goal for this lecture is, let me repeat that. Before you go into any type of small signal analysis, make sure you get this concept right. Let me tell you it's positive or negative, okay? This is the AC current, right? So look at this. Look at this. For the upper body, it's positive. For the lower body, it's negative. See, so if it's in the pink part, it's positive. If it's in the green part, then it's negative, right? So what kind of question is that? The reason I ask this kind of question, it's legitimate that you can ask me, sir, what kind of question is that? But you got confused with those kind of questions. So if you ask me, let me tell you clearly, here's the answer. Positive or negative. And here, in the pink is positive. In the green is negative. Positive, negative, positive, negative, positive, negative. Confusion, 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 confusion. Puzzle number 3. Why the AC current goes down? What's the right direction when it comes to the AC current? So you're going to do a lot of AC current analysis in the future. So when you draw any of the AC current, make sure you know this. Why the current goes down? It has to go down this way. Can the current goes up? Can the current goes up? The green is the only way, or there are two ways? Both are valid, or only one is right? Answer me. Both are valid or only one is right? Here's the answer. If you take the green, that means what? Means the IC equals GMVB. We prove this. What do you mean by the IC equals GMVB? GM is positive or negative. The polarity of the slope is positive, right? The slope is positive. What's the meaning of positive? GM. Means the in phase. Means the in phase. Means the output current is in phase with the input voltage. The output AC current is in phase with the AC input voltage. Sir, what do you mean by the in phase? Means the sync. Means that when the input voltage up, down, the output current is also up, down, up, down. You get it? So now, answer me. What about the purple? Can you do this way? Yes, you can. Yes. As long as you put on a negative sign. These two are opposite, right? So the negative sign means the two current. Green current, the purple current in opposite direction. And also the negative sign, negativity, also represent this type of current, this direction. The current is going this direction. The purple current is out of phase with the input AC voltage. Sir, what do we mean by the out of phase? Let me say this plainly. Out of phase means valley correspond to the mountain, the peak. And the peak corresponds to the valley. So out of phase means what? Not in sync. 180 degree out of phase means the up, down, and then down, up. Okay? Up, down, and then down, up, down, up. This means the out of phase. So these three puzzled is the three major takeaways. Number one, make sure you understand the concept of AC equivalent circuit. Don't try to get everyone involved. Take out the VC in the first place when it comes to the AC. Take out DC in the first place. Number two, positive or negative, don't ask this type of question. Okay, so because the AC is always repeatedly, continuously changing direction. Here's the number three. When it comes to the current direction, both are valid. If you take green, that means the in phase with the input voltage. If you take purple, you are also welcome, as long as you take care of the negativity, the negative sign. So we have come to the end of, I used the three lecture to cover some of the fundamental when it comes to AC analysis. So starting from the next lecture, I'm going to focus on the small signal model only for the MOSFET. So look forward to seeing you in the next one. Thanks for watching.